Hi, in this video we'll be talking about numpy arrays in more detail. We'll see how they can be created. We'll be using another Jupyter notebook here. And in the previous video we saw that it's easy to create a numpy array from a regular Python list. Here's again how we can do it. First, let's import numpy as np. And now here we have a regular Python list. Nums equals 5, 3, 8, 2, 0, 9, 4, 1, 6. Now n equals np array nums. Now this will make a numpy array out of this list. And now let's print our numpy array. Fine. And here's our numpy array. 5, 3, 8, 2, and so on. The same elements, but this time it's a numpy array. We can convert a tuple to a numpy array the same way. Have a look. Here we have a tuple. Now n equals np array of nums. Print n, and we get the same numpy array. We can create numpy arrays in quite a few other ways as well. Let's start with arrays containing evenly spaced values. We can use the arrange or the linspace function to do that. Let's have a look at the former first. In the following examples, we'll assume that the numpy module is already imported. The arrange function is very much like the built-in range function as far as syntax is concerned, but not identical. We can call it with 1, 2, 3, or 4 arguments. The syntax is arrange start, stop, step, dtype. So stop is the only mandatory parameter. It's usually not included in the array. If it's the only argument, the start parameter is set to 0. The arrange function returns a numpy array, which is of type ndarray to be exact. So let's use it. A equals np arrange 10. Print a. Shift enter, and here we have it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it works pretty much just like the built-in range function in Python. But this creates a numpy array. Now let's check the type of this numpy array. Type of A is numpy ndarray. Now let's use the arrange function with 2 arguments. B equals np arrange 5, 15. Print B, and now we get the numbers from 5 to 14, because 15 is not included. We are not limited to use integers as the start and stop parameters. Have a look at an example with floats. C equals np arrange 8.36. Print C. So if we don't pass the start argument, it will be set to 0 and the elements will be now floats between 0 and 8.36 with the default step of 1. If we use both start and stop, we'll get floats between the two and not exceeding stop, with a default step of 1. Have a look. D equals NP arrange 2.3 12.5 print D. This is what we get. 2.3, 3.3, etc. So the step is 1. And the last number in the numpy array doesn't exceed this second parameter. So the optional step parameter is by default set to 1. We can change this value to any integer or float value. Let's have a look at this example. E equals NP arrange 6.72 93.12 and the step 10. Print E, and here's our result: 6.72, 16.72, and so on. So now the step is 10, and the last element doesn't exceed this second argument. Or another example, F equals NP arrange 3.45, 3.47, 0.004, print F. And this is what we get. The last parameter, dtype, is used to specify the type of the output array. If it's omitted, the type is inferred from the input arguments. Here's how we can use it. G equals NP arrange 2, 10, the step is 2, and the dtype is float. Print G. As you can see, we get numbers from 2 to 10, 10 not being included, with a step of 2, and these numbers are floats. Now, the other function that returns an array with evenly spaced values is linspace. The syntax of this function is like this. The start and stop parameters are pretty straightforward. One difference is that by default, the stop element will also be included in the array. This is because by default, the endpoint parameter is set to true. If we set it to false, the stop element will not be included, just like in the arrange function or the built-in range function. Now, by default, the function returns 50 evenly spaced elements between start and stop. If you need a different number of elements, you can set the num parameter to the number you want. One thing to bear in mind is that the step is calculated automatically, so depending on whether the stop element is included or not, the step will be different. Here are some examples to demonstrate what we're talking about. So, first, we have 50 elements between 1 and 2, both 1 and 2 being included. Have a look. Print NP linspace 1, 2. And here's our output. 50 elements between 1 and 2. 1 and 2 are included, and these elements are evenly spaced. And now the same, but this time 2 is not included. Watch how the step is now different. So, print NP linspace from 1 to 2, and now we have to set our endpoint parameter to false. Okay, and here's the result. So the first element is 1 and the last element is 1.98 because 2 is not included, and the step is now a bit different. And now 4 elements between 1 and 2. 1, 2, 4 elements. And this is what we get. 1, 1.33 and so on, 1.66 and so on, 2. We have 4 elements between 1 and 2, both 1 and 2 being included. And if we exclude the stop value of 2, we get the following. Linspace, 1, 2, 4 elements, and endpoint equals false. Now we get the following output. We can also explicitly set the value of the dtype parameter, just like with the arrange function. This is what we get if we let the dtype be inferred from input arguments. Print np linspace from 10 to 100, and we need 20 elements. So this is what we get. And now let's set dtype to integer. So np linspace from 10 to 100, 20 elements. Now dtype equals int. This time we get integers. There is one more parameter, redStep. If we set it to true, the function will return a two-tuple containing the array and the step. So let's try it out. Print np linspace from 3 to 7, 20 elements, redStep equals true. And here's the output. We get a two-tuple. The first element is the array, and the second element is the step. Or we can use tuple assignment. R step equals np linspace 8, 20, 10 elements, redStep equals true. Print R, which is the array, and print step. And here we have it. Here's our array, and here's our step. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.